So welcome to Introduction to Python. I'm going to try to record the session and make the recordings available. And I'm going to tell you the story of that. Why am I doing that? Besides the fact that it's a good resource. I won't have a lot of time to invest into materials. All the more that I'm teaching this class just once, and because of that, I think it's good to have a recording of what's happening here, so you can review that. Mostly, what we're going to do is look at code and use essentially text files as a means of teaching. Let me introduce myself. I'm the guy. So this is my name. All right. With some of you, I have already communicated via email. The pronunciation of the name is Razvan Voicu. Some of you called me Prof. So don't do that. I'm an adjunct. I'm here just part-time. I work for a company called Teralytics, and I'm in the process of moving to Facebook. There's my place is not quite well settled. Because of my move to Facebook, where I will be traveling a lot, I won't be able to continue my work with Yale Linnaeus College, even though I like to. I enjoy doing that very much. This is it. And also because of that, the only link that I can give you right now is the LinkedIn link that you see there, or you can just Google my name. You're going to get to that link, and you can find a little bit more about me. So as I was saying, we're going to just do a very hands-on introduction. So before we start, I would like to know what your backgrounds are. How many of you have a computing background or are in a computing course? Show of hands. 1, 2, 3. That's all? Where is everybody else from? 4. Where is everybody else from? Come on. So let's start with you. Louder?
I'm a psychology major.
Psychology major. So everybody who didn't raise their hands, tell me where you're from.
I raised my hand.
Oh, you raised your hand. Next?
I did.
Oh, so I didn't notice it.
Oh, psychology.
Psychology as well. Interesting. Global affairs. Life sciences. Oh, interesting. So there's a gang of psychologists here. What? Life sciences. There's your hand? Yeah. You don't know yet. Okay. Anthropology. Hopefully math. Okay. Yes? Okay. All right. Cool. So how much math background can I assume? Very little. May I ask why you're joining this class? What are you hoping to gain from it? Because you see, so I didn't set a very long lesson plan because I was kind of expecting that some of you might not be computing majors, but then it turns out that most of you are not computing majors. So it means that I will have to change my approach quite fundamentally, which is fine, right? This is going to be a very interesting. I have never done this before, teaching programming to non-computing oriented students. But what do you expect to gain from this?
There are a lot of psychology.
I see. All right. So it's a means of processing data for many of you. All right. So then you would like the focus to be towards data science, data processing, doing statistics with data. Yeah? Just like, you know.
Analyzing trends in like a lot of data.
Sure. Okay. What's your expectation of, do you want to be able to survive as Python coders when you finish the module, or do you want to be, you're more interested in just using it as a tool for your work? I'm assuming that you're just interested in using it as a tool for your work, right? So I shouldn't be focusing on creating full-fledged applications, but rather, all right. Okay, that's interesting. Okay, that's very good. How much exposure to any kind of programming have you had before?
You know, basic R.
How many of you know basic R? Everybody?
Yeah.
All right. All right, that's better than nothing. Okay. All right, so one thing that I would like everybody to do, and most of you are already doing, is bring your machines to class. Do you call them computers or machines? Bring your machines to class, and by all means, we're going to try to do things together, right? So whatever I type, try to type alongside with me, and we want to see the results at the same time. And then if you have questions, you can ask, and then we will try to clear that out together as well. All right. So has everybody installed Python on their machines? At least that. How many of you haven't? All right. But you do have your machines with you. So how about you do that now? All right. It's a very simple process. What kind of machines do you have? I see a Mac. That one is a Windows machine. All right. So python.org. That's where you should go. Okay. And there should be a download. All right. And we want to use Python 3. All right. So the browser should recognize your operating system version and lead you to that. For Windows, make sure you install it for everybody. Otherwise, you're going to run in quite a bit of trouble. So when asked whether you should install for everybody or just for yourself, say that you want to install it for everybody on that machine. Right? The default is to install it just for yourself. Then, one important test that you have to be sure that everything is working is you should be able to run Python, okay? And you should be getting this prompt, right? On most Macs, the default Python is Python 2. So then you should write Python 3 and get it to work like this, all right? Pardon? Oh, you haven't seen the command line. All right, so you go to your app opener and you say terminal. And then you get an app that is called the terminal. Anytime. It's a predefined app, right? Obviously, the Python 3 command is going to work only after. Okay? So we need this because we want to be able to install packages, right? And the Python package installer is called pip. And again, I want to use version 3. Maybe I need to make this a bit bigger. Let's magnify it a little bit. Maybe even a bit more. So I'm pressing Command plus, and that is what makes it. So I would say pip3 install pandas forever, for instance, which is already installed. So it's going to say that it's. Oh, actually, it's not installed. Strange. But it was. And then this command will install packages, and I'm going to ask you to install packages every once in a while, right? It's all right. So can everybody check that they can do it? If you have installed Python, can you check that it can do this? And we will install pandas at some point. So you might as well install it now. And that will tell you that your Python environment is working fine. On Windows, right, if you install it for everybody, the way to obtain this command is by pressing the Windows key, the one with the Windows sign, right? The command key. So command and R, and inside there you say CMD and enter, and you would get a similar shell. This terminal, what's running inside it is a shell. All right, and inside that shell, you should be able to say again as well, pip or pip3, and install pandas and try installing. Did that work? Oh, so you haven't, you see that I typed Control D to exit, right? So Python 3, right? And I can type, I think, quit. So that's one way to quit. But the shortcut is Control, not Command, Control on your Macs and D. And that will exit. And after that, you can say pip3 or pip. So if you only install Python 3, you don't need to say, you don't need the 3. If the only thing you install is Python 3, you can say Python or pip. All right. Are we fine with this? Has everybody, yes? So you installed Python in your Mac or Windows? After installing, everybody else had no trouble with it? So when do you install it? Is it just installed right now? All right. So we won't need the pip command now, not in this lecture. All right. So that's going to be needed later. Okay, now Python in its predefined mode comes with what we call an IDE, which stands for Integrated Development Environment, right? Which is called IDLE, right? Which is a funny name because you're not supposed to be idle while you're working on it. So I'm going to say idle free or idle. Let's see if okay, this runs version 3 and it looks pretty much like this. Okay. So IDLE stands for Integrated Development and Learning Environment. All right, and we can use Python at this point, right? Python has two modes. There's a mode where it is used as an evaluator, which is probably the one we're going to be using most. If we're not targeting full-fledged applications, then this is the mode that we like most. And there's another mode, which we're going to still touch on later, which is the full application mode. Now, what you see here is just a nice GUI, a nice graphical user interface, but exactly the same thing we can get from the command line. And generally, professional programmers prefer this to this. Right? So I'm going to alternate between the two just to show you that the two environments are the same. So the simplest thing we can do is just evaluate an expression, and I think many of you have probably tried this, right? So these two environments work in the same way. And the difference is that, oh, there's no difference. Actually, I can exit from one as well as from the other, so then there's absolutely no difference. All right. One nice addition of idle is that we can edit text. So we can, at some point, right, get a window, and inside here we can say something like print 2 plus 3, and we're going to discuss the difference why 2 plus 3 and print 2 plus 3 behave somewhat differently in a minute, but this would be a valid Python program. The one that is most famous as the first program is this one, right? So this would be the programming 101. And what can we do with this? We can run it. So we can go here and we can say run module. We pick F5. We are going to be asked to save it. In saving it, we have to give it a name. So I'm going to call it test. I'm going to say save. And then the result of this program, the run of this program, happens here. All right. So you see this word restart here. The entire Python environment is restarted in the background, and we're getting a fresh Python, and our program is run. So a lot of what we're going to be doing is write stuff in this window and see it run in this window, right? This is going to be very much the way we're going to work. And if I were smart, I would have made the font a bit larger here. I don't know how to do that right now. I'm not sure why. Format. Preferences. All right. So what if we say 14 here? Maybe even 16. Okay, so this seems to be a bit better. All right, is everything okay so far? Again, please. What's the name of? Atom. So Atom is a bit more general. It's what we call a text editor, right? And you have an example of text editor here in this window, right? Atom is not coupled directly with any programming environment, right? So you can write Python code, but you don't have this interplay between the edited text and the interpreter, right? So here what we can do is directly send the program to the interpreter, right? And we can see it running. Now Atom has plugins, and some of the plugins may allow you to do the same. However, idle is the standard one, and it has the most standard functionality, right? So I don't want to inflict anything for you. If you want to have a really good one, a really good IDE, that is PyCharm, which is this environment, right? Which works in pretty much the same way, right? So this is a very professional kind of environment. I was gonna get to it at some point, and right. So you see the same program here, and you see the result of running that program over here, right? So we still have two windows, but one is here and the other one is here. We don't have interactivity though, right? Which for full-fledged applications is not that important. All right. So it's much more important. Interactivity is much more important when you learn. And in the first few months, people tend to stay very much in the interactive environment, and we're going to do that. But once they, become have a bit more expertise, they tend to not want that anymore. Okay, so we have two ways, two kind of outcomes of a Python program or of a Python fragment. One is the evaluation of an expression, right? So any expression has a value. Sorry. command to type in this window, and we get the result of that value, right? And the other way is to use instructions. So when I do print 2 plus 3, you see the 5, and it's pretty much looks the same, right? Looks about the same thing. However, what if I do I add 2 plus 3 here? Do you think I'm going to see the 5 or not? So I'm going to press F5, and it will ask me to save, and there's no 5 there, right? If I do put a print here, I'm going to see the 5. All right, F5, and I'm going to see the 5. All right, so print is an instruction. It tells the environment to do something, and that something is to print a value, and the value. So 2 plus 3 gets evaluated to 5, and the print command prints the whatever value was the result of that evaluation, right? So if I am in an external place, in an external environment, and I send stuff to Python, the only way I can see values is via instructions, like print. It's not the only way, right? But it's the one that we're learning right now. However, if we are in the interactive mode, which is here, right, we can type expressions, and as a courtesy, the Python interpreter tells us the value, right? It's an optional thing. The Python interpreter doesn't have to tell us the value, but because it's a language aimed at learning, it will do that for us. Okay? That simplifies things a lot. But be careful that whenever you write expressions in this window, unless you print them, you won't see the result. Right? Very often we're going to do things like this. All right, so I'm going to say that x takes the value of the evaluation of 2 plus 3. Then I'm going to, and before doing that, let me delete this, because otherwise it will confuse you very much, right? And let me delete this as, oops, let me delete it as well. So x equals 2 plus, and maybe we can take, you're going to get the impression that the only thing you can do is 2 plus 3, 10 plus 20. Okay, F5. So you see that the program has been sent to the interpreter, right? You see the restart here, but nothing was printed. Nevertheless, x has been defined. So I'm going to type x here, and I'm going to see the result. So very often we're going to do this kind of thing. We're going to have a complicated computation happening in this program, but we're going to visualize the results by explicitly asking for the value of certain variables. Is this clear? Okay, everybody can follow? All right, am I going too fast or too slow? Hard to tell yet, huh? Okay, so let's try to follow what I have prepared for today and see how that goes. So, I was thinking that this would be good reading for you, especially the first one. The first book is used in MIT as the introductory course to programming, right? MIT has always been at the forefront of teaching programming. Personally, I've been involved in quite a few courses that were, taken from MIT and deployed in various places. Years ago, I used to be a lecturer in NES, in the School of Computing, and I used to teach a language called Scheme that is the precursor of Python as a language for teaching computer science, computer programming. Right. So now I'm taking the current book, and I think it's a very good book. I think it is targeted towards data science, and I think given what you've all been telling me, it would probably be a good idea to follow that. Try to follow that. Okay. So we're going to try to look at some code. Okay, and I'm going to make this file available as well as the recording. All right, and we're going to try to take stuff from here and use it in our idle. So let's see if we try to use this as a piece of code, right? And while I'm talking, you try to type quickly. You don't have to actually type the entire strings. You can use AAA, something like AAA or ABC or DF. Shorter strings don't need to be pretty, right? These were chosen so that they would be pretty, but anything inside those quotes, anything that is the green stuff, any text you put there will work, right? So this is the print command. It is one of the most basic ones because any computation we might be making, we have to see the results of that, right? So the only way, not the only way, one way to do it is with printing. It will be our main way of doing that, right? You can see that print has multiple arguments. If you look at it, it looks like a function, right? Like a mathematical function. So it has a name, we open brackets. Inside we pass an argument and we close the brackets, right? And actually it has a variable number of arguments because we can use it in the first two lines, we can use it with just one argument, but in the third line, we can actually use it with two arguments. There's a comma, right? And there's another argument. The first string, and by the way, we call these strings, and we're going to come back to this. The first string is the first argument, and the second string is the second argument, all right? Now, notice that I put a space in here. This space is irrelevant. I can delete it. It will not change what we're doing, right? What the outcome of the program, right? But nevertheless, you see a space here, all right? So this is a standard feature of print, all right? So print will separate its arguments with a space. We can change this space into something else, and we're going to learn that later. All right? Print command, we have also learned that this is a string, okay? And we're going to find out more about strings. Okay, can we move on? Everybody has managed to run this? Cool. So, what else can we do? Well, we can put in an expression, and we're going to find the value of that expression, right? So we're going to also talk about different types of data, right? And when I say types, that's actually a consecrated name, right? There's a notion in computing called the type of a piece of data. And for every piece of data that we have, we can invoke this expression, right, with that value as an argument and find its type. So let's see what happens if we do that. And notice that I'm going to do that here. Right? How visible is it? And you see that it's a type called int. Int stands for integer. All right? And then I can do the same for strings. So I'm going to say ABC here. Right? And you can see that it's the type str, which stands for string. I can say type of 1.0. And we can see that this is yet another type called float, for floating point number, right? This is the way of representing real numbers inside computers, right? It's a number with a floating point because it has a mantissa and an exponent. Do you know what I'm talking about? What's the advantage of having a mantissa and an exponent in a number? The relative precision is always the same, right? So it doesn't matter. So for instance, if I keep 16 significant digits, which is the standard, right? It works out to be, actually what we keep inside is binary digits, but it works out to be about 16 decimal digits. When I say digits, is decimal, of course. If it's in binary, it's bits, right? If it's in decimal, it's digits. So about 16, and it doesn't matter whether the number is in the trillions or much bigger than that, right? I will keep the first 16 digits of that number and the exponent, because obviously we cannot keep all the possible digits of a number. It's not reasonable to expect that, right? But then we can encode numbers between 1 to the power minus 300 to the power, or 10 to the power minus 300 to 10 to the power plus 300, right? So a very, very small number, not negative, positive, but very, very small. So a very, very large number, right? Always keeping 16 significant digits, the first 16 digits, right? The relative error for that number is always the same, it's constant. So that's the advantage of using what we call floating point, right? A number that is in the range of 10 to the power 300 will have about 300 digits, right? But when we do our normal calculations, it's hardly, you can't possibly think that all 300 digits are relevant, right? Because if you have, in our manual calculations, you might have 4 digits, right? 4 digits after a decimal place. And then if you multiply them, you get 8. But what you're going to do, you're going to truncate and still keep 4. You're not going to keep the entire chain of digits, right? So it's pretty much the same principle. On any kind of calculation, we only keep the first 16, but that still allows us to go up to the power 10 to 300, to the power 300, right? So a reasonably large number. This is what we use as floating point. What you need to remember from here, because you're not going to remember all this blurb, is that we use different encoding for integers and for real numbers, right? So whenever we have fractional numbers, we use floating points, right? Whenever we want to keep integers as wholes with no error, right? We use integers. The range for integers is much more limited, all right? It's 2 to the power of 63, all right? Compared to 10 to the power 300. That's a much larger number. But, you know, so there are always trade-offs. So, strings, integers, strings, and floats. And there's yet another one. You know what true and false are? They're booleans, right? So you must have heard of Boole algebra and truth values, right? So the truth values, true and false, they're called booleans, and they belong to this class, bool. So similarly, since false, since there are only 2 of them, we might as well see both. Okay? Now, all these that we have typed inside type, they are constants. So I cannot say true equals 1. Right? I cannot say true or true equals false. Right? I cannot change the value of the word true. Right? And try to distinguish. Okay, we're going already into some difficult territory, but you see, I'm typing from the keyboard. As I type from the keyboard, there's 4 characters there, right? But Python understands these. You already see as how it changes color, right? And it recognizes the word and it becomes a keyword, right? And it assigns to this keyword. This keyword becomes an entity, right? It's not anymore 4 characters, but it's an entity, right? And these entities, they can be of various types, right? Some of them are variables, as we'll learn later, and some of them are constants. We're looking at constants. So these keywords, we cannot change their value, all right? So they are fixed. And for instance, so is while. We're going to learn soon. You'll see it in this orange color. That's something that cannot be assigned. You cannot give it a value. It already has a value. It already has a meaning. Okay, so we've seen the constants, all right? And we've seen that we can evaluate these constants, right? So if I say true, this is just a constant, but it's an expression. Any constant is an expression. We can type expression and get them evaluated, so therefore we get the value back. I can do things like true or true. And true or true is true. What are the Boolean operators? Somebody tell me louder. And Louder. What are the Boolean operators? No, these are the constants. The operators, or yes, XOR is a good one. Okay, we have our XOR. And true. What should give me? What should return? True and true. True, true, exclusive or true. What's the value? False. Right? True, exclusive, or true is false, right? Everybody? Yes? So when they're the same, it's false. When they're different, it's true, right? What else? Negation. Right? Yeah? Okay, good. So, Booleans. Strings. So, ABC is a string. We just saw that, right? We tell the computer this is a string, to Python that it's a string, by enclosing it in quotes. We can use either simple quotes, which is what you're seeing right now, or double quotes. And you're going to wonder, why do we need two types of quotes? Well, if I want to use double quotes inside a string, right? I can use double quotes inside a string that is marked by simple quotes, right? And if I want to say to use simple quotes inside a string, I can use double quotes. Okay. If I do this, what do you think will happen? You already see the change of color there, right? This part is of a different color. Why is that? Yeah, very good. So this is a string. This is another string, which is the empty string. And the hello word in the middle is nothing. It's nothing that Python can recognize. So we are immediately told that there's an error, right? So that's the advantage of having two types of delimiters. So the double quote and the simple quote are called delimiters, right? I can use the simple quote inside a string delimited by double quotes, and I can use a double quote inside a string delimited by single quotes. Is this clear? Right? It's a small point. It's in the grand scheme of things, this is just a detail. All right, we have string operators. What would be the string operators? What would be a good string operator to have? Concatenation, very good. Right? So the plus sign is overloaded, we say, has multiple meanings. All right? It can signify addition for integers and for numbers. It can also signify concatenation. Right? What else would be a good operator for a string? Louder? Multiply, yes. What would you expect to happen if I say ABC here? 5 times. Very good. Right? So this is a useful operator. Okay. By the way, notice the fact that whenever I evaluate a string, the result has the quotes. So this is an evaluation, right? What happens if I print? There are no more quotes, right? Why do you think that is? So it has to do with the fact that this is a learning environment, right? So when you evaluate, essentially you're in the learning mode. When you're doing this kind of thing, you're in the learning mode. So one thing you would like to know is the type of the result, right? If I just tell you ABC, 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 it's not apparent that the type is a string, right? However, when I print, this is what I would be using in a full-fledged app. In a full-fledged app, I want to be able to print whatever I want. I don't want the quotes. I don't want to see the quotes, right? I want to print regular strings on the screen as they are, right? So then what we print is what we get is with the result without quotes. All right. So yeah, pay attention to this these aspects, and yeah, hopefully you would have that question later, and then this answers it. All right. Let's see what else is there. All right. So we have Boolean operators, which, as you have seen, they can be either the bar and the ampersand, right, for or and, or they can be the keywords or and. All right. All the arithmetic operators are represented, and there's no big surprises here. All right. If you have no previous programming experience, let's just go through a few of them that are not so well known, right? So there's a distinction between normal division. So let's say I divide 5 by 2. We get the normal 2.5, right? But one very useful operation is integer division, right? Which takes the floor of the result. So that is represented by double slash. All right. It's an operation that can be very easily implemented with integers, and early computers only had this one. They didn't have floating numbers as well at all, right? And because that was the only operation that was available, then a very interesting class of math developed, and class of algorithms developed using only integer division. And this is still kept for historical reasons mostly, right? So that all those algorithms that have been developed are still possible to implement. All right, there's the modulo operator. What's the modulo? Or the remainder, right? Is the remainder of the division. So if I take something like 10 and I want to find the remainder of dividing it by 3, I would use this operation and I would get the result 1. The interesting thing is, what do I get for minus 10? All right. So if you, and why is that? Is this correct? What's the definition of remainder? What needs to happen? So 10 integer division by 3 multiplied by 3, right? This obviously is not going to be 10, right? Why? Because there's a remainder, right? So, oops. So plus, and now if I say 10% 3, this completes the picture, right? This should always be equal to the number. So now, what if I replace 10 with minus 10? This should always hold, right? So if I do minus 10 divided by 3, what should be the result here? Louder. Minus 4, right? And then minus 10% 3, minus 10% 3 should be 2, right? Why is it minus 4? Well, if I do minus 10 divided by 3, I'll get minus 3.333, right? The integer division is always the ceiling. The floor, sorry, not the floor, the ceiling, the floor, right? So 3.33 is between integers, minus 4 and minus 3. We always take the lower one, right? So then minus 10 divided integer division by 3 should be minus 4. Then the remainder is 2. The remainder of an operation always has to be positive. Remember that, right? This is basic arithmetic. It will appear, it will creep up on you. All right, so you will see other languages which wrongly will have minus 10 divided by 3 is minus 3, and minus 10% 3 is minus 1, right?
I don't get why
All right, so minus 4 times 3 minus 4 times 3 is minus 12. I need to get a minus 10. What do? I add 2, right? So if I add 2, it's plus 2. That's the remainder. Okay? Remainder always positive. Remember. All right. So these are operations that you might not use on a regular basis. All right. Power. So notice the following: that whenever we have an integer, right, the integer appears without a decimal dot, right? So it's 25 as opposed to 25.0. However, if I say 5.0 star star 2, I'm going to get 25.0, right? So 25.0 is a float. This affects what happens if you use this number in computations that result in bigger and bigger numbers, right? So if you start with a float, even if the computation involves integers after that, all the results are going to be floats. But then the advantage is you're going to lose precision. You're not going to have more than 16 actual digits, but you can represent numbers up to 10 to the power 300, right? Whereas if you want an integer, if you start with integer and use integers all along, you have the precision of the integer, right? Which is perfect, but it's limited range. So float trumps integer. Whenever a float gets involved, everything changes to floats, right? So 2.0 plus 3 immediately will result in 5.0, right? So this is a float. So just one number needs to be a float. Obviously, if both of them are floats, it's a no-brainer. It's going to be a float, right? So with the float trumps the integer. All right. One important thing that we need to do is comparisons, right? We need to be able to compare numbers. So these are expressions. And when I say 2 less than 3, what can you tell me about that, right? You're going to say it's true. So the result of a comparison has to be a Boolean, right? And now we are starting to see that the types get mixed together. We have already seen types getting mixed together because we used integers and floats together, and we didn't get rejected in using that, right? We got something that was a float, right? But types in general can be mixed together. I don't have power. Is there a way to get power to this thing? Could you help me? Okay, good. All right. So then we can write expressions like this one, right? So 2 plus 3 will result into an integer as an expression, right? And notice the fact that the expressions will be evaluated hierarchically. So we look at small pieces, we evaluate them, and we try to move up the hierarchy until we get a final result, right? So 2 plus 3 is going to be evaluated and produces the result 5. Then, once we have a result 5, we're going to compare 5 and 5. And this will produce false, right? Then we go to the other side. We're going to evaluate 7 remainder 2, 7 modulo 2. The result is going to be 1. Then we're going to go to this big expression and we're going to ask, is 1 equal to 1? The result is going to be true, right? So then we're going to have false from here and true from here, and the result is going to be false. False and true is false, all right? And this is always the case, right? We can build arbitrarily complex expressions and they will get evaluated hierarchically. Okay, so here what's going to happen? Well, we're using brackets. So 2 plus 3 gets evaluated first, right? We get 5. Then, what happens with these operators? What do you think the order should be? Should we perform star, the multiplication first, or the division? Multiplication, why is that? It's from left to right, exactly, right? So multiplication and division have the same precedence, right? And they would be evaluated. Associativity is left to right, right? Associativity is left to right. So we evaluate the left one first and then the right one. And we're going to get the result 3, right? Whenever we are not happy with the order of the evaluation, we can change that using brackets, right? Parentheses. All right. And this is pretty much all that we have about constants and expressions involving constants. Okay. One fact that you might not be very well aware of is, I think I'm going to make this a bit smaller so that it gets to the middle of the screen. Maybe for some of you it's easier to see. All right. So what do you think? Okay, let's try this one. What do you think this one, how will this one be evaluated? So, in other words, what do you expect? Is this going to be equal? Is this going to be true? Actually, I don't know. I never tried. It shouldn't be true, right? So the standard is that exponentiation is, the associativity is right to left. So this would be false, and it's correct. I never tried it in Python, frankly. All right. So if we do this, right, this is going to be true. Okay. So if you're curious, oops, so Control P will repeat previous commands, and I'm very often confusing it with Command P, which is a printing command. Okay, so we can see that, and now going here, we're going to see that this is a completely different result. And notice that they're very, very large numbers, right? So exponentiation is an operator that associates to the right. Is that clear? Yes? Also, if we do this, which one is evaluated first? The power operator, right? And also, if we do this, right? Also, the power operator gets evaluated first. Okay? So you can play with that. Just be aware. Whenever in doubt, use brackets. Okay? You should know that precedences and associativities vary across languages, right? And I will never test you on associativity and precedence known by heart, right? And I will never penalize you for using too many brackets. That's because I don't know them, right? So I work in many languages on a day-to-day basis, and I will never trust to know the nitty-gritty of every language. This kind of tests were at some point in SOC, were especially for the Java module that was being taught at the time, people were given this tremendous, very long expressions and asked what is the result, and they were supposed to know the associativity and precedence of all the operators in Java. I thought it was one of the worst way of testing. Don't worry if you don't remember this, but be aware of the fact always that it might not be what you expect. Okay, so always test, and whenever in doubt, use extra brackets. So we move to the next important aspect of Python, which is variables, and any programming language, right, which is variables. And if you have some basic knowledge of R, you've learned that in R. In R is a left arrow, right? Assignment is a left arrow, and these words are whatever we choose them to be. Obviously, we cannot pick those keywords that we have already seen, right? We've seen quite a few. Or, and, true, false, right? So those were words that we cannot use as variables or identifiers. So these words that we're inventing here, which are of our own choosing, we call them variables or identifiers, all right? And they can take values, and their value can change during the running of the program, all right? What's the advantage? Well, when I say that they can change during the running of the program, the obvious advantage is that you can use them as memory, right? You can use them to store something for a while and then store something else, and so on, right? So this will be a very important way of using it. But if you look at this, right? Many of you might remember that pi is 3.14159, right? Most scientists, if they ask for the value of pi, they would know about 6 digits, right? But obviously, this is far from the most precise representation of pi, which will have a lot more digits, right? Which you won't be able to remember. So then, it's much more useful to use a keyword, to use a name for that value, right? Which is this one. In doing that, you're actually providing meaning to values that otherwise they would have a meaning, but it would be difficult to, it would not be available to you immediately, right? Because of that, we always want to pick very meaningful names, right? In many programming courses, you'll see variable names such as A, B, C, names that don't have a lot of meaning, right? We're going to try to stay away from that. We're going to try to give meaning, to use meaningful names for our variables. All right? Notice that now that we can take an arbitrary expression and take advantage of the values that we have put in our variables to create new values, right? So pi and diameter, they have their own values. Instead of pi, I could have used 3.14159 directly in this expression. Right at this place, I could have used the number instead of the name, right? But I choose to use the name. Why? Because pi times diameter squared is a much well-known formula, right? And if you see 3.1459 times 11.2 squared, you would not know that that's the area of a circle, right? Whereas if you see this, you immediately think this is the area of a circle, right? And then this area would produce a result. And this is a piece of code that we can actually run. So let's go here. Right, I'm going to press F5, and right, all the computation has been performed already. You don't see any result. Why? Because we are inside here, we are in full-fledged mode. So if you don't print, you don't see anything. However, once the computation has finished, we can very easily just ask for the value that we want to evaluate, right? And we will get it. If we were writing a full-fledged program, we would have said print area here, and now this we can run from the command line. I can go to the command prompt, I can say Python 3. I'm curious whether this would be, let's do that experiment as well. We have a test.py somewhere. Problem is I don't know where this file would be. Oh, it's in documents. Okay. Right, so we have a test.py here. It's the file that was saved. And I'm going to say now Python 3 test.py, and you see the printout, right? So it essentially becomes a command of the operating system at this point. I can do something even better. I can take this and take advantage, but this will not work in Windows, unfortunately, of something called the shebang. So if I put, we haven't talked about comments, but you have seen comments already. So let me talk quickly about comments. These are comments. They start with a sharp sign. That line is ignored by the by Python, right? So this line that I'm writing here is ignored by Python, but it is not ignored by the shell, which is the terminal window, right? So if I write this in there, okay, the shell will see it and will invoke this command and pass this file into Python, right? And then it becomes a standalone piece of code. So now I can say, test.py. I need a lot more stuff. So I need to give it permission to execute. So I'm going to say +x. And now you see it running as if it were. So you don't see the word Python here, right? I can even copy it into a file that doesn't have the py extension. And if I say test, right, it looks like it were an operating system command, right? This is, for instance, this is the command of running, seeing the contents of a folder. In Windows, that would be dir, D-I-R. And then this test runs exactly like an operating system command, right? So we can write, this is like a full-fledged application right now, right? We're going to get there, and we're gonna say a little bit more about that, right? But this is why the print command is important. This is why we want to have it, because most of the Python code is like that, right? It's a full-fledged application, and whatever the user sees is whatever is printed. Clear? Is this? Does it make sense? Okay, you're going to get used to that for sure. Am I going too fast? No. And I can actually get rid of that. So my computer is not properly set up. But one thing I can do is something like and now it should run without this. Yeah, this is not a good name. Let's give it a different name. So let's call it area. All right. So I don't need the // anymore. It's yeah. A well set up computer will not have that problem. Okay. So clear variables. All right. One very interesting and unique feature of Python is multiple assignment. We can change values of variables. We can assign multiple variables at the same time, right? So I can say something like A, B, C equals 1, 2, and 3, right? And now if I print A, it's 1, B is 2, and C is 3. One interesting feature of this, one interesting side effect of this is that I can exchange values of variables, right? So the result of this is that A has become 2 and B has become 1. In most languages, this kind of feature is not available, right? So how do we exchange values of variables in that case? You would use an auxiliary value, typically TMP, and you're going to say TMP equals A, then A equals B, then B equals TMP, right? So this exchanges the values of A and B, right? So in Python, you don't need to do that. This will suffice. Okay? It's a very convenient thing. All right, so these are the basic elements, right? The basic elements are constants, expressions, and variables. With this, we can already do quite a bit of computation, right? So are we ready to move on to procedures and functions? We're not going to finish today, but we can at least start, okay? And that will give you something to play with. All right? So, one difficult thing that I need you to understand right now is why we need them, right? So procedures are very similar to functions in mathematics, right? It's very common to say I define f of x to be sine x plus cosine x, right? So you've done that in math, right? You've defined your own function, right? So we're doing something similar here, just that you're going to see a bit later that it's a lot more than that. But let's stick with this kind of meaning that it's a mathematical function. So we have a function that returns the distance from origin for a point whose coordinates are x and y in the plane, right? This is 2D geometry. We have x and y, and we're computing x squared plus y squared and the square root of the result of that, right? So this expression should be very easy to interpret, right? You understand very easy what it is, okay? And whenever we want to return a value from a function, we have to use the keyword return. It's just the way it works. The keyword def tells Python that we're going to define a function. This is the name that we pick for the function. This is a name of our own choosing and has exactly the same rules as any variable. You've seen the variable diameter, you've seen the variable pi, any kind of name that we want to choose, we can choose for a procedure. And then we have to say what the arguments are. And this is pretty much like in math. And Python will ask us to use the colon here to say that what follows is the definition of the function. And then another important thing is that we have to indent. We have to leave this space. All right? We cannot do this for a definition. We can do this. This is allowed. This is not allowed, but this is allowed as well. So the indentation opens what we call a block. We're going to talk a bit more about that. And right, the block ends, right, starts essentially at the column, and it will end whenever we write something in the first column. So if I'm going to define another function, because this function starts in the first column, this tells Python, oh, this is where the block has ended. The definition of the previous function ends here because I start a new a piece of text in the first column. All right? So let's use this function. All right? So you see the restart, and there's no printing, right? but we know that the code has run. So this now is defined, and we can use it. And I'm just going to copy the name. All right, and we can use two numbers as the coordinates of the point in question. And you might remember from your 3D geometry that 3, 4, and 5 are the sides of a rectangular triangle, right? A right triangle, and then the result should be 5, right? 9 plus 16 is 25. The square root of that is 5. That's what we get. Okay. Now, the interesting thing is, if I'm going to evaluate this, so no brackets, just this, what do you think we're going to get? Why would you expect error? Right? Does this look like an error? So, not an error, right? It's not something that you can interpret either, unfortunately, right? But it's not an error, all right? So, we have, let's think of the concepts, right? We have numbers, they're objects, right? We have strings, they're also objects, right? Floating point numbers, but therefore just numbers. I can have, in mathematics, I can have sets of numbers, I can have tuples of numbers, those are all objects. And I can have functions. Aren't functions objects? Are functions objects? They are, right? Can I talk about a set of functions? Obviously, right? Can I talk about a function of functions? Yeah, right? Give me an example of a function of functions. The derivative, right? The derivative takes sine and gives you back cos, and takes cos and gives you back minus sine, right? And takes x squared and gives you back 2 times x, right? So notice when I say x squared, that's not the variable x. X squared is fx equals x squared, right? It's a function, right? So a function is an object, and in Python, it can be manipulated as an object. It's on the same level as a number, right? It can become an argument to another function, for instance, right? So remember that. So we distinguish between the function as an object and the application of a function, right? Since previously we could write pi, so pi is no longer there. We had pi equals 3.14, right? Now we're going to ask why this works. And it works for a very good reason, but all in due time. So I can say pi, and I get that back the value, right? Then distance from origin is just an identifier. So I should get back something that is not an error, is an object, right? Now, this object is a piece of code, and that piece of code can be millions of lines of code, right? So obviously, Python is not going to vomit all the code on your page. It's just going to tell you it's a function, right? It's very easy to say whenever it's a number, it's very easy to print the number, but whenever it's a function, since a function can be so complicated and convoluted and long, it will not bother to tell you what's the inside of that function. It will just tell you that it's a function, right? As soon as we do that, we know that it's a function. We can try to apply it. If I apply it to a single argument, I'm going to get an error, right? If I apply it to the wrong number of arguments, right, obviously I'm going to get an error. But this is a function. Why do we want these procedures? And we're going to see later why we call them procedures. For the time being, they're functions, right? One, this as a name is a lot clearer than this expression, right? If you see this expression, is not immediately clear that it's the distance from origin, right? But if you see the name there, that is self-explanatory. So I want to use a function because it makes the code clearer and more modular, right? I also, what if I have to use this expression in very many places in the code? Well, instead of using this expression, I just use the invocation of this function, right? And this is likely to be shorter, right? Imagine that instead of this simple function that we have put on the in our program, we would have this expression. This is a lot longer, right? Imagine that you have to use this function in 100 places in your program, right? You would have to write this expression 100 times. Instead of writing this expression, you just write its name. So that certainly saves a lot of effort. Is this clear? There's one more important thing that beginners don't think about, right? You will realize that when you become more experienced coders. What if this expression has an error? You just realize, oh, this should not have been 1.5, this should have been 2.5. Imagine you didn't use a function. Imagine you copied this expression in 100 places in your program. Now you have to go in 100 places and make the correction, right? So having this definition will allow you to make a single correction, right? So these are very important. These are very important advantages of using procedures, right? And we want to have them. We're going to do a lot of stuff with procedures, especially because they are objects, and we're going to see a lot of very, very interesting and quirky programming from that. But let's establish a new rule. From now on, right? I'm not going to use standalone standalone expressions and programs. I'm going to put everything inside a procedure. So my program, whatever I present to you, I'm going to put it into a procedure, and we're going to have the procedure into this code window. So I'm going to go here and have the procedure, and then I'm going to go here and run my program by essentially evaluating the procedure, invoking the procedure, right? This makes things a lot easier because I can invoke now the procedure with multiple arguments, and you can see different ways of running the same thing. Okay, so let's take this program. Okay, I'm not going to tell you what it's doing. Let's see what it's doing first. So I'm going to run it, or load it, better said. And now I can say evenness of 10. And yes. Right? And I can also say evenness of 11. And you see how easy it is to run it twice with different inputs. Okay? For now, at this point, these values are the inputs to our algorithm. And what we return is the output from our algorithm. Most of our algorithms, whatever we're going to discuss, are going to have an input and an output, or multiple inputs and multiple outputs, right? And this is a very convenient way. If our program is already a procedure, we can invoke it multiple times with multiple inputs and observe for each set of inputs the output. All right? So I'm introducing procedures so early, it's not customary to do that. I'm doing that precisely because this is a very convenient way of coding, right? Procedures do not interact with each other. Therefore, I can take another procedure, for instance this one, and I can add it to my program, and the first procedure does not interfere with the second procedure. So then I can load them both and I can compare them, right? If I use standalone programs, most likely the two programs are going to interfere with each other, and because of that, it will be difficult to have them together in my evaluation and compare them, right? But in this case, with procedures, it's a lot simpler. Okay? So we can still run, because of the way we work, we can still run this, the first procedure, but now we have a second procedure. And guess what? If I press tab, we also get auto-completion, right? We see that evenness2 is defined and a function. And we can run it, right? And we can run it for 11 as well. And we see that the two functions do the same thing. Okay, now let's explain what's happening inside here. So you see the keyword if, right? And obviously what you're expecting is that if, and what you see here is a Boolean expression, something that returns true or false. So if true, do something, if false, do something else, right? That's pretty much what we expect. So if this expression is true, perform this action. This is called the consequent of the if statement. This if is an if statement. Now, if has an optional part which is called the else clause. And if the expression that you see here is not true, that is, if it is false, we perform the instruction in the else clause, which is called the alternative, right? So we have a consequent and an alternative. All right. So obviously, if k is modulo 2 is 0, which means that k is even, we return the string even. If otherwise, we return the string odd. Okay. Now, in Python we also have what we call a functional style, right? So we want everything to have a value. This statement does not have a value, right? It gets the function gets a value because of the return statement, but the if itself doesn't have a value, right? So for instance, I can say something like if true, then 3, else 4. And I can't do 3 and 4 on the same line. So if true, 3, oh, and actually it does have a value. That's very interesting. That I haven't seen before. Parts of Python that I haven't seen, because I'm not using the evaluator much, right? I'm in full-fledged application mode, right? But we want a functional style, right? So we can write it differently and make sure that this expression has a value. All right, and in that case, we can use a single return statement. So this statement, I'm going to take it out from here. So let's say I define k to be 3. And then if I evaluate this expression, this k that you see here already has a value. I have defined a value for it, right? So it's odd, and this is going to be false. And therefore, we're going to go for this side of the if statement, right? And it's going to have, oh, I have deleted it. All right. Then we can change the value of k. So I was telling you that variables are very useful as memory, so we can change its value. We can make it 4, and if I run this is even, right? So this is a different syntax, right? And I can make the entire expression have a single value, right? It's like a conditional expression. What does this resemble? This resembles the following mathematical construct. We used to have this function definitions, fx equals, and then we would have something like a big brace. I wish I could write on a piece of like this big brace. Right, and we would say here it's equal to, say, 0 if x is less than 0. So this would be the sine function, right? And it's equal to 1 if x is greater than 0, and maybe this is less than or equal to. Remember this kind of definition in math, right? So this expression that you see here is exactly that type of definition. Is this clear? So if I were to write the sine function, which there is a predefined sign function, of course, but so this thing should have should be a command. All right, and the sign function of x, I could define it as return, and I could say 0 if x is less than 0, else 1. Right? Looks a bit weird, but works. Okay? Notice that we don't need to use the colon here, and we can use any kind of expressions we want, but we cannot use statements inside the if and else clauses. Okay, we're gonna stop here. But before we go, so typically what I used to do in NUS was set up this IVLE homepage for the course. Are you all able to access that? I was sent a link to a canvas or kind of, but I'm not familiar with that, so I think I'm going to stick with what I know. I don't have a lot of time to devote to the module, unfortunately, because of my move to Facebook. Yeah, I'm going to try to make all the materials available, including video recordings. There's a forum, all right? And you're all invited to bug me as much as you want with questions on the forum. I prefer the forum rather than the email because it's obviously what we discussed can then be perused by everybody, right? So it's for the benefit of everybody, of the entire class. These are my email addresses. Maybe you want to take them down now. And one thing I would like you to do is send me an email, each of you, because it's easier to keep track of everybody. And if I need to, until I set that up, if I need to tell you anything, I'm just going to have a mailing list and send it to you. Any questions about today's class? Yes. I'll have to think about that because you're at a completely different level compared to what I expected. I also don't quite know how the assessment is going to be. Is it just assignments? Can I just do it based on the assignment evaluation, or do we need to have an exam at the end? Do you know? Again? You're sure about that? Because well, okay, I'll ask. So in NUS, it's not always up to the professor, right? So the if it's a 4 MC module, definitely there has to be an exam. But since this is 3 MC, maybe, and it's only half a semester, maybe the rules are a bit. If that's the case, then we're going to start assignments next week, right? And we're going to run assignments for about 5. This is 6 weeks or 7 weeks? 6 weeks. Yeah, so we're going to run about 5 assignments with increasing level of difficulty, and if it works the way, you know, I mean, I don't have to have a final exam, then I'm just gonna you're gonna get a grade out of that. I didn't know the level of the class, so therefore I had no idea at what level I should prepare assignments. I think already what I have prepared for next 2 classes is a bit too advanced, so I'll have to tone that down. As you can see, I've gone through much less than I wanted to go through in the first class. Yeah, obviously it has to be done in a way that benefits you the most, right? So, and your feedback is going to be crucial in terms of that, because I haven't taught a class at this level. So by all means, if you think I'm going too fast or I'm pushing stuff that is too advanced, then you just fight back and say we're completely overwhelmed. So maybe some topics are not appropriate. Yeah. So So my plan is to start the assignments next week. You're going to have a 1 week deadline for each of them. They're, they should be very doable, generally. Um, yeah. Is that okay? That answer? Yeah, but I think I'll stick to one assignment per week. Given how many of you are here? Probably not all of you. 2, 4, 6, 8, 10, 12, 14, 16, 17. So there should be 20, I think, in the class. 19. So yeah, there's only so much marking I can do. That's also, yeah, there's a limit there. Cool. Good. See you next time. Yeah.
Where can you access these notes?